My name is Sam Gallagher,
And my name is Nathan Marks.
and we are doing our senior project on a facility design and analysis of a battery pack assembly. In this video, we are going to go over the introduction to our project, our problem statement, a little background on why we picked it, a few key assumptions to begin the design phase, the methodology behind our project, and what we plan to do as we move forward.
Sharpell Technologies is currently looking to evaluate a proposed battery pack assembly line for their electric automobile, which at the moment is still in the design and prototyping phase. This is an example of the battery pack extremely similar to the one that Sharpell Technologies is currently in the process of designing. A basic breakdown of the components in each pack is as follows. There are 12 modules in each pack, a compressor with cooling system and lines, bus bar, which is connected to the modules, and then a rubber buffer along the spine, a high voltage connection next to the motor, a main cooling system, a mother BMS, fire retardant lines, the top, and then a plastic casing that goes on top of the aluminum. We have determined our problem statement to be the following. Sharpell Technologies currently needs to design and evaluate proposed battery pack assembly lines for their electric automobile.
As of now, Sharpell Technologies is looking for recommendations on how to proceed with the manufacturing component of creating their electric vehicle battery pack. Currently, Sharpell needs a simulation and supply chain analysis to help aid in the planning stages of their electric vehicle production.
Based on the literature review as well as conversations with our client, we have determined that there are a few assumptions necessary to move forward with the design of the process and the facility. For this reason, these assumptions are justified and will be solidified once we move on into the methods portion of our project. They are as follows. Sharpell Technologies will be producing 25,000 units a year. The modules and pack enclosures arrive line side, and the required times for individual processes is difficult to determine because they are so specific, so we must rely on similar processes as well as triangulation to determine these times.
The overall design or methodology we will follow is established in the following order. Research current electric vehicle manufacturers to assess competition. Establish battery pack assembly processes for Sharpell Technologies vehicle. Propose alternative facility designs for battery pack assembly. Simulate production for each design and observe the differences. Analyze proposed designs to determine the optimal layout. Evaluate economic feasibility within the U.S. in regards to facility and materials.
This is the current design of the assembly process in a flow diagram. Aluminum enclosure first arrives line side, as well as the pack, so it is lifted onto the AGV. Then a non-conductive sticky sheet is applied. Then the cooling lines are installed, followed by module installation, bus bar installation and high voltage connection, and then mechanical and electrical connections are torqued out and connected. It then enters a buffer before moving on to high voltage testing. Then the top plate is installed, followed by a leak test and an air test. Then it enters another buffer before the final stage, the charging station, which is when the pack is tested as well as given its first charge. And then finished goods inventory.
Here we have a proposed SketchUp layout using the most current steps of the assembly process. It begins with the bottom plate being placed on an AGV and then proceeds through the steps mentioned in the previous slide. Of course, this is only one possible layout, and our group is currently in the process of creating others as well as beginning to create them in Simio.
As we move forward with our project, we will continue with our previous design to accomplish some of our established objectives, and will begin experimentation and analysis in the near future.